Today I'm at a state meeting, so since I didn't want us to lose any time, you have this recording to watch. So make sure you know that there will be a quiz attached to this, as well as you have a review assignment today to take care of. I will not be able to answer any emails today because I am in that state meeting. So let's go ahead and get started. We've got a warm-up question. I would like you to translate the sentence into an inequality, then decide if it is true or false. So looking at the question, I'm going to start off by finding where our sign is. So there I find is greater than or equal to. Remember that is greater than or equal to. Greater than looks like a lazy 7. Or equal to has the line underneath. So everything to the left is going to be, to the left of is greater than or equal to is going to be the left of the sign, and everything to the right is going to be to the right of the sign. So we've got 8 1/10 minus 4. So 8 1/10 would be 8.1 minus 4 is greater than or equal to 2 times 2. So we have 8.1 minus 4, that's 4.1, is greater than or equal to 4. All I did was simplify the two sides. So I took 8.1 minus 4, that gave me the 4.1, and then 2 times 2 gave me the 4. So true or false, is 4.1 greater than or equal to 4? So it has to answer one of those two correctly. So it's definitely not equal to, otherwise they would be the exact same number. It is, however, greater than, it's more than. 4.1 is greater than 4. So that makes this entire statement true. So here are some applications to inequalities. First of all, I can write an inequality that would solve a given word problem, and I can solve a word problem involving inequalities. So here's some examples of inequalities that we don't think of in our everyday life. For example, if you're driving across a bridge, a traffic sign before a bridge warns weight limit 24 tons. So if you were to write this in an inequality, I would use W for weight, and I'm relating it to 24 tons. And ask yourself the question, a weight limit, does that mean that the weight can be greater than or less than 24 tons? And in this case, the limit means you can't exceed it, you can't go above it. So 24 must be the greater of the two. Okay, so the weight must be less than 24, or it could be equal to. So weight is less than or equal to 24 tons. I go above that 24 tons on that bridge, and we would start being concerned about that bridge's viability. Let's see, next one, the qualifying time for an Olympic marathon is 2 hours, 37 minutes. What that means is, in order to run in the Olympics, you actually have to run the marathon in less than that time. Anything less than that time. So if I say time, the time you run your marathon in, and I'm going to put over here 2 hours, 37 minutes, my time better be less than or equal to that amount of time. So my time is got to be less than or equal to 2 hours and 37 minutes. If I run it faster, in any greater amount of time, then I'm not going to make it for the Olympics. And trust me, I'd be thrilled, absolutely thrilled to get a 2 hour, 37 minute Olympic marathon. That's running, 26.2 miles? That's insane. Okay, water is liquid at temperatures between 0 and 100 degrees Celsius. So there's a trick between would insinuate to me that 0 and 100 are not included. So it's between 0 and 100 because at 0, it becomes a solid, and at 100, it becomes a gas. So I'm going to put, it's got 2 in there. When you've got 2 values, 0 is the lower, 100 is the higher. And I'm going to put T, capital T for temperature. And I'm going to end up looking like this. 0 is less than the temperature, which is less than 100. And that statement right there, that would give me the temperatures in which water is a liquid, given we have normal atmospheric pressure. All right, so the internal temperature of a cooked turkey should reach 165 degrees Fahrenheit before it is considered safe to eat. Important because we know Thanksgiving's coming up, and cooking a turkey is part of Thanksgiving traditions. So let's go ahead and let's see. That means 165 is okay. 166 is okay. 167 is okay. But 164 is not. So again, I'm going to use T for temperature. 165 is what I'm comparing it to. I know that 165 is okay, so or equal to is okay. Now the question is, does the temperature need to be greater than or less than 165? Think about what it should be. And I want my turkey to be any number greater than 165. 166 is good. And if it helps, think of an absurd number, like think about 10. Okay, put 10 in. 10 is greater than, well, 10 when I don't want my turkey to be 10 degrees. That's not going to be safe to eat. That's raw turkey. That's disgusting. So that wouldn't work, and that makes sense. That wouldn't work in this inequality that I've put together because 10 shouldn't work. 10 is not considered safe to eat. But 166, sure, 166 is greater than or equal to 165, and I would consider that turkey now safe to eat. So just some helpful ways to consider how
that
to evaluate whether or not you wrote the inequality correctly. To screenshot, to write down, because you're going to have a lot of these show up. We don't always just say, is greater than or equal to. Often we'll say other terms for it, but it means one of these. So, for example, if I were to use the phrase is under, then that means this less than sign. Just less than. If I were to say is at most, that means less than or equal to. If I were to say is no more than, that also means less than or equal to. If you were to say exceeds, that means the greater than sign. If you were to say is at least, that is the greater than or equal to. And then is not less, I like to think this as is not less than. So is not less than, not less means greater. So is greater than. But is not less than, not less than. So if it's not less, here are your options. Think of it as your options are to be less than, to be greater than, or to be equal to. Those are your 3 things. It's saying is not less than, you still have those 2 other options. It could be greater than, and it can be equal to. So if you see is not less than, that means greater than or equal to. Because really you have 3 options. So hopefully take a screenshot of that and remember those. Those are the phrases and what symbol they go to. So hopefully you took a screenshot of that, because here you see is at least. So we're going to need the is at least. So hopefully you remember what the is at the least 83, what symbol that would be. So Jake is 1 year. Notice this first sentence is actually an equality. It's an equation because the word here is. Whenever we have, writing, sorry. Whenever we have an is, that is an equal sign. So I'm going to put J for Jake and F for his father. So taking that first sentence right here, it says Jake is 1 year less than. Remember, less than means subtract, but in the wrong order. So less than, that means I subtract 1. And it says half his father's age. So 1/2 F. So this is Jake is 1 year less than half his father's age. The sum of their ages, okay, so the sum of their ages is at least 83. Moving to the next sentence. So sum means add. I'm saying the sum of the two ages, J plus F, is at least. Ooh, what sign was that? Is at least. Is at least means greater than or equal to. So it's important to remember those signs because a lot of us would see least and go, oh, less than. It's saying the lowest value it could be is 83. The lowest value it could be is 83. So if the lowest value it could be is 83, that means it's got to be greater than 83. Okay, so I'm going to fill in that 83 there. Now, what is Jake's youngest possible age? I'm going to take this right here and I'm going to plug it in for J. So in the place of J, I'm going to put 1/2 F minus 1. This is a property of substitution. I can substitute something as long as it is equal to. So I substituted 1/2 F minus 1 in for J. And now I'm going to collect my like terms on the left side. So on the left side, I've got 1/2 F and then an F. That's a half plus a whole. That gives me 1/2, or I'm going to write that as 3/2. So we have 3/2 F minus 1 greater than or equal to 83. So now we want to go through our SADMEP and go ahead and solve this. So we've got plus 1 to both sides. Moving to the top, running out of room, sorry about that. So we've got 3/2 F greater than or equal to 84. In order to get rid of a fraction, remember we multiply by the reciprocal. The reciprocal of 3/2 is 2/3. That causes my 2's to cancel, my 3's to cancel. So I've got the father is greater than or equal to 84 times 2 divided by 3. Grab a calculator. I'll make sure that I'm doing it right, but grab my calculator. And I get 56. Okay, so now I'm going to plug that back in because look, it says what is Jake's youngest possible age. So I want to go back and I need to plug that into Jake's age because that was the father's, F for father. So I'm going to go back over to Jake's equation. Jake equals 1/2. I just found the father to be 56 minus 1. Half of 56 is 28 minus 1. So Jake's youngest possible age is 27. So 27 is the youngest possible age that Jake could be. Because think about it, if Jake is 27, then his dad is 56. 27 plus 56 is 83. And we were looking for numbers equal to 83 or greater than 83. So if Jake was 26, if he was 1 year younger, if he was 26, think about how old his dad would be. If Jake was 26, his dad would be 54. Hope you got a chance. So 26 and 54. So if they're 26 and 54, and you add those together, that would be 80. Not quite there. It has to be at least 83. Okay, so Jake is at least 27. Youngest possible age, above 27. Okay, guys, this is a really big one that's going to happen a lot. Trying to find what profit and revenue are. So, and then there's cost. So make sure you realize profit is the money that you get to take home. Profit is how much money you get to take home. Revenue is how much money you actually get. And then cost is how much money you had to spend. So if you think about a typical job, for example, if I were to babysit for a friend, and or if you guys are babysitting ages, if you drove yourself to the babysitting job, but it costs you $10 to get there, that's your cost. They paid you $20, that's your revenue. How much did you really make? And that's 10. So I cost 10 to get there. They paid me 20, that's my revenue, but I profited 10. So the way that we find profit, and this is a really is going to show up a lot, guys. So please remember that profit equals revenue minus cost. So big thing, a business makes a profit when the revenue is greater than the cost. So look at this, revenue greater than cost. If this number is bigger than this number, revenue bigger than cost, then you're going to get a positive number. If your revenue is less than cost, for example, in that babysitting scenario, if I were to, cost me $10 to get to their house, and they only paid me $5, I actually lost $5 in the deal. Not a great babysitting job. Okay, so you want to make sure the money you get is greater than the cost so that you have a positive profit. Another thing to point out, what if the revenue is equal to cost? If they're equal, for example, if I were to spend $10 to get to a babysitting job and then they pay me $10, I did not profit anything. I'm at zero. It's better than losing money, but I'm still at zero. So looking at this example here, Elliot will work as a landscaper over the summer. He buys $240 worth of supplies. So that is a cost. Okay, it cost him right there. So I'm going to go ahead and circle that one. This is a cost, and it's one time. That's a one-time cost. But then he also will spend $10 each week on advertising. He's got to print out his flyers, walk around. He's got to get staples to staple them to trees or whatever it is he's doing to advertise. But that is a weekly cost. So that's reoccurring. If he earns $80 each week, okay, so that's a revenue. It's not saying he profits. It says he actually is taking in $80 each week. So we had two costs and a revenue. How long will it take him to make a profit? So let's write an expression for each of those. Cost, in this case, he's got the $240 he spent initially, plus he's spending $10 every week. So it's times the number of weeks. So if the summer is 2 weeks, it'd be a horribly short summer, then he spends $20 on advertising plus the $240 initially. So that'd be $260. If he goes for 3 weeks, that's 10 times 3, that's 30, plus $240, that's $270. His revenue equals $80 a week. So it's times the number of weeks he works for. How long will it take him to make a profit? So we want this, we want revenue minus cost to be greater than or equal to 0. That's when he starts making a profit. So I'm going to set this equal to 0. I want my profit to be 0. Really, I want my profit to be a very large number. But I want my profit to be greater than or equal to my revenue minus cost. Okay, revenue minus cost is my profit. I want it to be greater than or equal to P. So I'm going to go, let's see, go ahead and plug your numbers in. So I've got revenue is 80W. Careful, I'm subtracting a sum, so I got to put that in parentheses. And I've got 0 is greater than or equal to. I'm going to distribute that negative. So it's minus 240 minus 10W. So, greater than or equal to. That would give me 70W minus 240. So I'm going to pause there, and I'm not going to show my work for this next part because I would like you to be able to do this on your own. So you want to figure out the value of W there. And I'm going to tell you the correct answer is technically 3.42. Depending on how the question is worded, you would want to answer this after 3.42 weeks. Now again, this could be interpreted that you would have to round up to 4 because after 3 weeks he hasn't quite made a profit. It's actually after that 3.42, but we don't think of weeks in terms of decimals. So you might need to make it into an integer or a whole number. But if you answered after 3.42 weeks, that tells me you did your math right. So at 3.42 weeks, his profit is 0. So anytime after 3.42, that's when he actually has a profit. So think about working somewhere for 3.5 weeks and you haven't even taken home a paycheck yet. He's taken money in, but it went to pay off the supplies he bought. So the correct answer is after 3.42 weeks. Now this is going to show up, this is a tricky one, possibly wink wink nudge nudge on a test. So I want to review a few terms. First of all, consecutive means one right after another. So consecutive integers are whole numbers. So a consecutive list of integers would be whole numbers, one right after another in order. So 1, 2, 3, 4, 5, that would be consecutive integers. Let's see, 3 million, 3,000,001, 3,000,002, 3,000,003. Those are consecutive integers. So you're looking for whole numbers in order, not skipping around. So the question here is the sum of two consecutive integers is greater than 105. So let's interpret some of this. First of all, they've helped us out by just giving us is greater than. So it's just the is greater than sign. The right side is 105. Now we need a way to represent two integers. So a nice way to represent an integer is n. Okay, just a variable, a whole number. Now if n is an integer and the next integer is the one I want to write, how would you represent it using n? And to do that, I'll give you a little table. Let's start with 7. Let's say 7 is n. How would I write 8 in terms of n? Well, 8 is 7 plus 1, right? So if I put it in terms of n, I'd call it n plus 1. Hopefully that makes sense. So the first integer is called n. The second integer is called n plus 1. So the sum of two consecutive integers would be n, that's the lower of the two, plus n plus 1. That's the next one, it's one higher. All right, so I've got my equation written. I'm going to go ahead and collect my like terms. I've got 2n plus 1 is greater than 105. I'm going to subtract 1 from both sides. And I've got 2n is greater than 104. divide by 2 on both sides, and that gives me n is greater than 52. Now, that's our answer, but go back, make sure you actually answer the question. It says find the least pair of integers. N has to be greater than 52, so 52 does not work. 52 does not work because that is not greater than 52, that's equal to. So my numbers, the next, I want an integer, so I want a whole number. So the next highest whole number is 53. And that says it wants the pair, so 2 consecutive numbers. 53 and 54 are consecutive and they're whole numbers. If I add them together, I get 107, which is greater than 105. Now, if you're not sure, maybe it could be the next lower set of numbers. The next lower would be 52 and 53. Add them together, you get 105. Remember that the sum has to be greater than 105. 105 is not greater than itself. It is the same. So this one doesn't work, but this one does. So correct answer to this one is 53 and 54. All right, so which inequality models this problem? We've got the length of a rectangle is 3 times its width. So this first one, notice in this sentence, there's no inequality here. The length of a rectangle is, if it's just the word is as your verb, then you're looking at an equation with an equal sign. So length is 3 times its width. If the perimeter is at most, okay, so what symbol represents is at the most? Hopefully you saved. So the greatest number is at most means the greatest number it could be is 112. The greatest number it could be. That means it needs to be less than 112. Is at the most, I like to put the in there, is at the most 112 means that that's my cap and I need to stay below that. So that's going to be a less than. But it can be 112. So perimeter is less than or equal to 112. Now I'm going to put in the place of perimeter the equation for perimeter, 2 length plus 2 width is less than or equal to 112. Now here's where you're going to have to do some substitution. We know the length is 3w, so in the place of length I'm going to put 3w plus 2w. All right, so I'm going to simplify. This is 6w plus 2w. That's 8w. To get rid of that 8, it's being multiplied, so I'm going to divide both sides by 8. Grab my calculator and make sure I don't mess up my math. And I get 14. So w is less than or equal to 14. So what is the greatest possible value for the width? It's 14. Now notice something. I did this problem. I didn't actually have to do the problem. If you look over at the answers right here, I actually didn't have to solve it, did I? And actually, to make it even easier, these are all the same on the left side. They're same on the right side. The only difference between each is the symbol. So whenever I made my decision of that symbol right there, the less than or equal to, I could have gone right there. I actually didn't have to solve it. This bottom was correct. The rest, they're all the same. It's just a question of what sign I was going to use. So making sure you know is at most means less than or equal to. Okay, so another problem. Which inequality models this problem? Josephine started a business selling cosmetics. She spent $4,500. So remember, spending, that's one of her costs. And that's to obtain her merchandise. So she's got to buy the, the mascara, the eyeshadow, the lipstick, etc. So this is a cost. And it costs her $200 per week. So the first cost, this one, the $4,500 is a flat fee. It's not per week. It's just $4,500. But the $200 is per week for her general expenses. I don't know what that means. I guess she has to, drive places, etc. So that's a cost. And then she earns $550 per week. So that's her revenue. So one thing about profit and revenue and cost is your profit occurs whenever your revenue, okay, so you want your revenue to be greater than, because when it's equal to, you actually haven't made a profit. Your profit is zero. You haven't earned any money at that point. You've just paid off your bills. So you want your revenue to be greater than your cost, and that's when you will start making a profit, when your revenue is actually greater than your cost. So revenue, I've got 550 times the number of weeks, greater than, okay, my two cost values, I had 4,500, that's the flat fee to buy all the makeup, plus, and then the amount to drive places, etc. Okay, so notice I didn't have to solve this problem. I don't have to figure out what the W is. This question is actually asking me just to match the equation. So if I look through, I believe that one matches my equation. So I didn't actually have to solve for W. I just had to find an equation to help me solve for W. Okay, Mia is 3 years older than, so Mia is, again, I see an is without like a greater than following it. So that means that this is an equation. This first sentence is just an equation. So Mia is 3 years older than, that gives me addition, twice her sister Brooke's age. So 2 times B. Twice means multiply by 2. The sum of their ages is less than 30. So here's my is less than. It tells me I have an inequality. Is less than is just my less than sign. Sum of their ages, that's going to be addition. So Mia plus Brooke is less than 30. Now I'm going to go ahead, and at this point you couldn't solve this bottom equation because you have 2 variables. So I need to take this equation and I'm going to substitute 3 plus 2b in for m. So I've got 3 plus 2b, that represents my m, plus b is less than 30. Left side, collect my terms. I've got 3 plus, and I've got 2b and a b, that's 3b, less than 30. Subtract 3 from both sides. And I've got 3b is less than, got ahead of myself, is less than, 2 mistakes in a row. 2, there you go. Okay, sorry, that should be a 27. All right, and then I want to get rid of that 3, divide both sides by 3. I've got b is less than 9. So Brooke is less than 9. So it's asking me what's the greatest age she could be. Looking at my options, okay, less than 9, so 10's definitely out. Is 9 an option? No, it's not. It says Brooke is less than 9, less than 9. So that means that 9 is not possible. So the greatest, now both of these, 7 and 8, both fit. They're less than 9. But the question is, what's the greatest she could be? So out of those two, 8 is the greatest age that fits it. 9 doesn't because she has to be less than 9. So you're looking for that 8 there. All right, the sum of two consecutive integers. All right, so remember, consecutive means one right after another. Integer means whole numbers. So the lower integer would be n. The next one, it's 1 greater than, so it'd be n plus 1. Is at the most, so the greatest it could be is 223. So is at most does allow for 223, so it can be equal to, but it means it's got to be less than or equal to. Is at most means less than or equal to. Okay, so we've got n plus 1 is less than or equal to 223. I'm going to go ahead and simplify. That's 2n plus 1 less than or equal to 223. Subtract 1 from both sides. We've got 2n is less than or equal to 222. Divide both sides by 2. N is less than or equal to 111. So the question is, what is the larger of the two integers? So remember, n is your smaller. So the larger of the two would be 1 bigger than that, so it'd be 112. So 112. So my two values are 111 and 112. The larger of the two would be 112. All right, Vanessa has scored 45, 32, and 37 on her 3 math quizzes. I hope these are out of 50 points, not out of 100. She will take one more quiz and wants a quiz average of at least 40. Okay, so this one's a little bit, you gotta go with me here. So she's gonna take a total of 4 quizzes. She's taken 3. She's gonna take one more. That's 4. So you gotta ask yourself, how do you take the average of 4 numbers? So it's talking about the quiz average. You want to take the average of 4 numbers. So to take the average of 4 numbers, you go number 1, that sounds weird. So your first number, all right, first, plus your second, plus your third, plus your fourth, and you divide by how many you added together. So that's 4. And she wants it at the least 40. So 40 is okay, but she really would like it to be greater than. I mean, think about, you want your quiz averages to be higher than a certain value. So she's looking for this equation to be true. Her first quiz plus her second quiz plus her third quiz plus her fourth quiz, add those together, divided by 4. She wants that to be greater than or equal to 40. All right, so now what we're going to do is we know 3 of those numbers. So we're going to put those in their places. So the first one is 45, plus the second one is 32, plus the third one is 37, plus she doesn't know her last quiz score. We're going to call that x. Divided by 4 is greater than or equal to 40. All right, so go through your SADMEP. First thing you want to do is multiply by 4 on both sides. Okay, because remember that fraction bar makes the top a parentheses. So you don't have any addition or subtraction because the only addition is inside that parentheses. So you have to get rid of the 4 first. So multiply by 4. Let's see, right side becomes 160. Left side, I'm going to go ahead and simplify for the interest of space. 45 plus 32 plus 37 is 114. Okay, all I did was add those 3 together. All right, so she's got 114. That is, I'm going to highlight. So 45 plus 32 plus 37, that gave me the 114. So 114 plus x is greater than or equal to 160. Now I'm going to subtract 114 from both sides. that gives me x is greater than or equal to, right side we've got 160 minus 14, and I believe that is 46. So her next quiz has to be at least 46. That's the lowest she can get. Now I want you to look at her grades and go, is that likely? She's got to do better than she's ever done. So hopefully she is studying up a storm. So the last one, 214 is a practice test. I would really, really, really recommend going through 214 and doing that practice test. And the reason I'm going to recommend that is because your part 2 of this test involves what we're doing on 214. So if you want a good part 2, that's the written part, it all comes from 214. All right, so 214 is how to justify why are we allowed to do what we do. Why are we allowed to do each step of an equation? So here over on the right are the basic properties of numbers. And these might be helpful to jot down and remember. So first, this is called the commutative property, and it says for addition and multiplication, my order doesn't matter. Okay, so adding a plus b and b plus a, here's an example, doesn't matter what order I go in. Same thing with multiplication. Man, this may be the worst possible color to try to put there. This is called the associative property of number. And basically it means when I put parentheses, associate, think like who you are close to, who you're around. When it comes to addition and multiplication, again, division and subtraction, it doesn't work. I can group with addition and multiplication, and it doesn't change my final answer. So what they have here, this says a plus b plus c equals d is the same as, I can regroup it as a plus and then put the b plus c in parentheses, just in case you can't read that. And it's similar with the multiplication. So it means I can associate, notice the b associates with the a in the first one, and it groups or associates with the c in the second one, but it still will give you the same overall answer. Let's see, bottom left, that's called the distributive property, which we've used in class before. So when you're adding two numbers and then multiplying by a number outside, it's the same as multiplying that number out front by each individually and then adding them together. All right, and then some identity properties. Adding 0 remains the same, hence identity is who you are. So adding 0 to something doesn't change what it is. The other identity, this is the multiplicative identity. This is the additive identity because I added and multiplied over here. So multiplying by 1 does not change the identity of the number. So when you're justifying steps, you have to give a reason. Why are you allowed to do what you just did? So follow through what happened, and the easiest way to do this is really ask yourself what actually happened between each line. So looking from here to here, ask yourself, what did they do? Nothing on the right side changed. All I see is over here, the 1/3 got distributed. Okay, they went 1/3 times everything in the parentheses. So looking over at your options, I see, oh, that's the distributive property of equality. I can distribute the numbers. All right, so now you go back and go, okay, so my justification, the reason I can do that, you've got to find a property of math that justifies what you just did. Distributive property of equality says I can distribute the numbers and it's still equivalent. It's still the same. All right, so now you've got to compare what happened here to here, what happened between these two steps? They're not showing you what they did. You've got to figure out what they did. So I notice m over 3 is the same. I notice the plus 7 disappeared. So remember, at this point, what you would have done is subtracted 7 from both sides. So I want you to remember, if you subtract a number from both sides, that is called the subtraction property of equality. It says that I can subtract the same number from both sides of an equation and it remains equal. Again, so the subtraction property of equality says I can subtract a number, in this case 7, from both sides and the equation stays equal or balanced. So I subtracted, subtraction property of equality. Now again, compare the two. What did I do from here to here? And notice your reasoning goes on the lower of the two levels. So from here to here, I notice I multiplied by 3. It's very similar, property of equality, property of equality, property of equality. Okay, these are all properties of equality. So the multiplication property of equality says I can multiply both sides of an equation by the same number and the equation remains the same. So the reason I get to do this is the multiplication property of equality. So which property, and again, just try to focus one at a time. These are just some different examples. So looking at the top left right now, which property could be used to justify the transformation from line 1 to line 2? So ignore line 3. Okay, we're going to do that later. Right now, we just care about what happened between here and here. So the first thing you really want to do is just ask yourself, don't worry about why can I do it? I want you to ask the question of what happened? I notice my half x is the same, but I notice my plus 3 went away. And my left side is less by 3. So I must have subtracted 3 from both sides. All right, so ask yourself, I subtracted, and guys, that really should be your first hint as to what the answer is. It's the subtraction property. Some people will say of order, some people say of equality, as long as you get the subtraction part right. So it's called the subtraction property of equality, subtraction property of order. Says that I can subtract 3 from both sides and my equation still stays the same. All right, looking at the top right, which property could be used to justify from line 2 to line 3? So ask yourself, what happened? So I notice going from here to here, my half disappeared, and the left side is plus 5, or double. So you can kind of look, well, I could have added 5 to both sides. That would explain it, but it doesn't explain the right side. So it's not addition. There's no way I could have subtracted that. Okay, comparison property of order has to do with switching the direction. So I didn't flip-flop anything. So what I did, I must have multiplied. In this case, I did. I multiplied by 2. Each side was multiplied by 2. So that's the multiplication property of order. All right, bottom left. Try to see if you can answer it before I get there. So which property could be used to go from line 1 to line 2? So again, compare them. What happened? So if you look through, I notice, okay, so the 65 is still there on the right, but the 2n, the negative 2n disappeared on the right. So in order to get rid of a minus 2n, I must have added 2n, and that would explain what happened on the left side as well. So I added 2n to both sides, so the key word there is I added addition. Look at your options. I've got addition property of equality. Okay, last one. Going from line 2 to line 3, what happened? I noticed that my negative 5 on the left side is gone. So in order to get rid of it, I must have divided, because it's currently being multiplied by n. So I must have divided both sides. So again, I just said, oh, I divided division. So this is the division property of equality. So really you're asking yourself, what am I doing between each line? And then you're finding a property, a real life math property that goes along with it. Okay, so it should be one of those properties, either the associative, the distributive, the commutative, the identity. If you want, I could write these down. Okay, so your options here. You should have either the distributive property, that's if you distributed, and I'm going to say POE because I don't want to write it out each time. PO. Okay, property of equality, that's what POE stands for. Okay, there's associative, that means I changed where my parentheses were. Associative property of equality. Let's see, there's commutative, which is the actual property that says I can go in any order with addition. There's the identity. The identity property of equality is the one that says I can add 0 or I can multiply by 1 and they don't change the identity. These are the options. These are the reasons you can give. There's the multiplication. You might see multiplicative. That's just a fun word. Multiplication property of equality. There's the division, the addition, and the subtraction. Those are the reasons you can give. 99% of the time, your reason's going to come from this list. All right, so here's the full list of the reasoning you can give. Again, I'll run back through them. Distributive means you distributed a number outside the parentheses to all the numbers inside the parentheses. Associative property of equality means you change the placing of your parentheses, but it has to be just for addition and subtraction. Commutative means you change the order. So A plus B, you turned it into B plus A. Identity property of order means you added 0 or you multiplied by 1. Multiplicative or multiplication property of equality means you multiplied both sides of an equation by a number. Division, you divided both sides of the equation by a number. Addition, you added a number to both sides. And subtraction, you subtracted a number from both sides. So that is your list. Your reasoning for each line should come out of this list right. Password for 928 is reason. So you've got A, B, C, or D. Which equation solution set is the set of all real numbers? This is actually kind of a review. So remember, all real numbers means you end up with a totally true statement. So make sure you can work through those. Go take the quiz for this. So just to clarify, for today, for Wednesday, September 28th, you should take the exit ticket. Password is right here on the board right now. You should take quiz 213. You should take practice test 214, and guys, practice tests are extra credit. And then you have the review video assignment. That is separate. Okay, so you have 4 things to do today. One is just this 1-question exit ticket. You got a 5-question quiz. The practice test is extra credit, and then you have that review assignment. All right, good luck.